So guys, I want to show you, before we do this, this next practice problem, I want to show you a couple things here. I found two articles real quick. What I normally do is I go to Google and I search the word study for the last week, and then up pops these studies that I've done. They're kind of timely sometimes. One of them deals with sleep and how it relates to heart health. Associated sleep duration and quality with subclinical atherosclerosis, some kind of heart condition. Not a medical doctor. Look at, let's see. Here's the results. There we go. Right in here, you can see some things that look very familiar. 95% confidence interval, 1.06 to 1.52. Tell me, remind me, there's a P up there. What's the P value again? Is it, the P value was the probability that the mean is in the right place, right? It's the probability that we just happen to get a sample that was that far away and the mean's in the right place. So when is it more evidence that the mean is in the wrong place? You got to really think about this. Is it more evidence when the p-value is bigger or when the p-value is smaller? More evidence that the mean is in the wrong place when the p-value is bigger or when it's smaller? I love you guys so much. If the p-value is the probability that the mean is in the right place, a smaller p-value would be more evidence that it's in the wrong place. Are you guys kind of with me? So in journal articles, you'll never see alpha worth shit. You'll never see alpha anywhere because they just report the p-value because everybody might have a different level of what's proved. This p-value of 0.008, that's low. That is really good evidence that whatever it is actually has an effect on each other, right? That there is a difference. So in this case, they're trying to see if short sleep duration was associated with this bad thing about the heart. And they got this probability that they weren't associated. So it's more likely that they are associated. Do you guys follow? You guys follow a little bit? When you read a journal article, one thing is you will see confidence intervals all over the damn place. But you'll also see these p-values. And the smaller the p-value is, the more evidence there is that there was an effect. There was some relationship or an effect, something's different. It's evidence that something is different. This one was kind of neat. This was about striped body painting in certain tribes and how it decreases them being attacked by horseflies. So you can have different tribes with different striped body paint. And they figured out that zebra pattern actually makes for less horseflies attacking people. So I mean, here's let's see. There's a p-value right there. So I'm not going to get into the specifics of the study, but you guys will now be able to get an article, get a journal related to something you're interested in. There's journal articles about music, about business, about psychology, about whatever the shit. There's journals for everything. And if they're trying to prove something, they must use this. And you will see confidence intervals. You'll see p-values, right? And now you'll understand what the hell that means. So, let's see if I can find this real quick. Oh, where are you? I saw you. Look at this thing. Holy shit. 0.999. That is not significant. You see, that means that that's definitely not evidence. That's huge p-value. So that's like, holy shit, that's not evidence of anything. So you'll see not significant, and you see a very small p-value, that's significant, that's evidence. That is sufficient evidence that there's something changed. Maybe? Not really? Shit. Alright. I just like to show you everything we're learning from day one almost. You can see that being used in the real world. It's a standard way to kind of look at things. And again, if you ever see something saying p-values are shit, p-values are not shit. If you misinterpret them, then you're shit. The p-values are fine. They mean what they mean. It's just that we often misinterpret them. You guys kind of with me? One of my favorite. Has anybody ever heard of XKCD? XKCD? It's a webcomic that's sort of mathy, so if you haven't, I don't blame you for not. Let's see, where's the one? I'm not going to find it, am I? Here it is. Oh my God. Well, let's not have butts showing up. That's the funny thing about Google search. You can search for the most innocuous thing and have
all kinds of shit showing up.
Alright, script, I'm not going to find it. But basically one of these, it's just really cool. You don't have to like understand all the math to be able to read some of these, and they're not all mathy. They tested each jelly bean color separately for an effect on something, and one of them, so they did 20 colors, and one of them showed evidence. So what's that? 1 out of 20, that's 0.05. So if you're using an alpha 0.05, you expect to get a false answer 1 out of every 20 times. So that's why this whole idea in science about replication of results. Okay, you got a result. Let me see if I can get the same result, because maybe you just happen to do that one time out of 20. That shows the wrong thing. It's got to be able to be replicated over and over before it's really bought into. Are you guys semi with me? That's why it used to feel like 1 week eggs were good for you, and the next week they were bad for you, and the next week it's because people were publishing the shit too early before they peer reviewed it and compared it against other things. Cold fusion. I don't know if anybody ever heard. That was another example of, oops, not really. So, enough of the real life stuff. Can you bring the lights back up? You on? So, here is the practice test. On the other side is what I want you guys to do right now. I'm going to leave you out on your own for this one. We'll do it together after you're done. So this is the practice test. Do this side, the hypothesis test practice. Do that. No, Monday's a holiday.
That's the class period for me. I paid for it.
He's probably going to give us some blood.
Can you believe I'm slash
It's because it's sequence.
I'm friends with you. I've gotten great grades in all my major classes. This is going to be my first below B grade for sure. Well, that's what I want to get my bachelor's in. I mean, this is just forensic technology. So we like learn how to like take pictures of crime scenes and real fingerprints.
One of these?
Yeah.